So let's talk a little bit about Sheetcam, how it brings in files, how it recognizes files. We're going to look at different colorations, things that Sheetcam automatically does to let you know how your file is going to look. So I'm just going to go File, New Part, and I'm just going to import a random one here. Let's go with SVG files here, and we're going to go with let's go with this one. All right, so I bring everything in a 1-to-1 ratio, and you'll see here that there are three colors present on the screen. We have the white, which represents line segments. We have yellow, which represents shapes that are inside of other shapes, and then we have red, which is an outside shape. Now, if you look at your screen, you'll notice that if your part looks, and I'm just going to do something real quick here, move to layer all for one. Let's go. And we're going to do this one here. Move to layer, color 0. Okay. You'll notice that my entire shape is red. The entire shape being red signifies that you may have one or more layers in your art file. That's the first thing that I noticed when looking at your piece. You may have one or more layers in your art file, which is perfectly reasonable and something we can definitely take care of. The way we do this is there is a small C tool here called Edit Contours, and we just square select the entire piece, right click, and then click Move to Layer, create a new layer, and just call it All, and then hit OK. And by doing so, we now have our interior shapes being recognized as interior shapes and exterior shapes being recognized as exterior shapes. And the reason this is important is because when the plasma cutter goes to cut, it needs to know what parts is going to cut from the inside of and what parts is going to cut from the outside of. Otherwise, it will cut on the outside of inside shapes, and essentially we want to know where to put our blade width, and Sheetcam does a lot of that automatically. So just keep that in mind here. Now, once we do bring the file into Sheetcam, the next thing that we have to do is tell it what type of operation we're doing. Once we've imported a part, that's just the first step. The next step is we're going to go into operation, and I'm going to say plasma cut. Now, I have something called 16 sim in here, which is just something that it's a tool that I've built, but your system should have a series of tools pre-built into it. And I chose my 16 gauge, and then under layer, I also selected my all layer. That is everything that I put all of this onto the all layer. So I'm going to be cutting the all layer. And when I load my 16 gauge simulation tool, it'll automatically give me the feed rate that's pre-built into it, which is the 230 inches a minute for this file. Once this is all said and done, I also have lead in and lead out. Lead in places the pierce point of the torch outside of the part or inside of a dropout on the interior of a part, in order to make sure that when you are cutting, you don't see the dimples or the little excess burnout that's caused every time the plasma cutter pierces. So the lead in and lead out moves those away, and we'll see that here in just a moment when I do hit OK. So we have our contour method, outside offset. That says that we're going to cut it on the outside of this part on all of the red, and then on the interiors we're going to cut on the inside of the yellows, and then the white is going to cut right along the line. We also have options of inside offset and no offset. 9 times out of 10 we're going to be sticking with the outside offset unless we're doing something really tricky. Of course, as I said, 9 times out of 10 outside offset is what you're going to use, because that's how people mostly cut. We're trying to cut something out of a material, so the blade width is going to be on the outside of the shape in order to preserve the accuracy of the shape that we're trying to create. Then I hit OK, and you'll see that my entire screen has turned green with colors, and we have blue lines here that represent all of our G00 travel. That is the rapid movement between parts here. You'll notice that I have these little tiny arcs here. That's what I was talking about with our lead in and lead out. This allows us to put the pierce point on the interior of the shape so that when it does burn, it doesn't burn out onto the piece. Let's go ahead and zoom out here, and there we go. See, we have all of our cut spaces. This, if we can tell, it understands plasma kerf width isn't going to give us the cleanest corner, and it compensates for that, and it will recognize that this is actually cutting, this is the outside, this is the vector that it's trying to cut to, and it's cutting on the inside of that vector. And if we go to an outside shape, it's actually cutting. Here is the white line. You can barely tell that it's here in the video, but it is just barely there, and that represents the outside of the shape. And it's going to, there we go, there's a good one. This shows us that this is cutting on the outside of the outside shape. And that's why we do inside and outside offsets. And you'll notice here, again, we have our little tiny lead in and lead out for every part. It doesn't have to look exactly like this. There are multiple ways to do this, but you'll notice also as well that this vector line, this single solitary line, represents a line segment that's being cut. There is no lead in or lead out on line segments. So keep that in mind. And let's take a look here, see if there's anything else I can point out. Nope. So once we've gotten it to this state, once we have our little S numbers, which are our start points, if we want to adjust those, we can always just click on this S plus tool, and then move our start points to wherever we want to put them. I would just recommend using the defaults put in by Sheetcam, unless, of course, you find an error in it and you just double check and go, oh, okay, I don't want it to cut there because, you know, I don't like the way it's positioned. Yeah, as you start to work with the CNC Plasma more, you'll find little nuances that you want to keep in mind when working with it. So back to the pointer tool. Once we've gotten to this point, all we have to do is go to File, Run Post Processor, and this allows us to turn that into a G-code. We hit OK, and that's done. But only after you put the operation on there, and only after you've told it exactly what it's going to be cutting. In this case, I told it it's going to be doing 16 gauge steel. It'll cut 16 gauge steel at 230 inches a minute, and this is the path that it's going to follow. Let me know if that makes sense. If you have questions, please feel free to reach out.